Thanks. Topic today is chapter 12, which is, thank you, that helps a little bit. Yeah, that's fine, that's better. Because chapter 10 is not as important, it's on functions, although functions are important. Oh, I wonder if I turn this on.
Yes, it's on.
Okay, thanks. This is on low volume, that's why. Okay. So we are done with everything except chapter 10 on functions and chapter 12 on files. Files are a little bit more important. Functions are useful too. I'm not telling you that they're not. So they are useful, but we'll do them last. They're not as useful as files are. Okay? So ask me a lot of questions because it's not an easy chapter and you can expect at least one problem out of 5 on the last exam out of this. So it's up to you to try out some problems. I'm not giving you any assignments, but there are plenty of problems at the end of the chapter, okay? Do some of those. And there are examples on code samples. Oh, before I forget, somebody pointed out a nice website for Python tutorials. Could you remind me what it was? Coward. Could you remind me of the website?
It was
Pythontutor.org or something?
yeah.
Pythontutor.org. I think it was that. It's sort of coming up.
Google search Python tutor.
Oh. Okay, no
It's one
problem.
of the first results if you Google Python visualizer.
Okay, no problem. I'll Google it. So today it's a Western movie. Google. They keep changing every day. Python tutor. Online Python tutors. Is that the one?
PythonTutor.com.
.com. Oh, I said org. Okay. This is a very nice website, I believe. I haven't tried it out in some time now. But this is a definition of a function, and this is a small list, and they're calling the function list sum to add up all the numbers in that list of lists. So it should produce 6, right? And you can do it step by step. And are there others? Or is this the best one? There's so many. Python tutorial, online Python tutor. That's probably the one. Yes. Write Python code here and then run it. Visualize execution. So let's just do 2 lines. Print 2 to the power 1000 and print 2 to the power 10,000. Okay? 2-line program. Now in a lot of languages you won't be able to do that in Java, JavaScript. Anyway, all you have to do is you can edit the code anytime, but just press forward. It's done the first step, but the output is so long that you got to slide this bar to get the full output, right? And was it fast? Yes. And then go forward 1 step. You got the second line of output, which is longer, right? The first line ended somewhere here. You see that? 76 is the last 2. Anyway, so you can write any program and run it step by step. Now you can do that in our Python language as well. Did I ever do that? Maybe not. And let me go back to one of the samples. Pick one up, simple one maybe. loops, something on loops maybe, nested loops, no, nested for, I don't see loop anywhere. Let's say pay example. I should have done it, I don't remember if I did, but since, 2.7.8, that's okay. One of the options is to run it line by line. I don't remember if I did that. Debug. So what that does is let you run the same program line by line. And all you have to do is step forward. I don't see that anywhere. And it'll show you all the variables here. Let's see. I click on this line. Does anyone remember? Debug on. So I suppose we can. Does anyone remember if it's a function key or what, which lets you step by line by line? Okay, that's why I didn't do it, I think. Options. Oh yeah, now I have a rough idea. In this, you have to click on step or over. But why is it?
Maybe you have to tell it to run.
Oh yeah, tell it to run. Thank you. That's a good idea. Now it's allowed. Okay. So these are the file name, etc. And once you tell it to run, you can step and run. See, it's telling you that it's not gotten into the program yet, basically. Or is it waiting for input? Here we are. It's waiting for the input now, right? So you put in the rate. I don't remember what the input is, 5%. Oh, $5 per hour, $10 per hour. Okay, so then you have to say step again. And you can look at the variables somewhere here. See, it was at this line. It's grayed out again. Anyway, it also tells you every line it does for the input and so on. So it's probably waiting for some input. Let's close this because I don't like to do this because there's always the print statement. Why not do that, right? You can always put more prints in this program. So it was waiting somewhere here. So I do a plain run with debug off. And you can always include prints. See, enter rate of pay, $12 an hour. Enter hours worked, 50 hours. And the output of this is this, $660. But this is running in 2.7.8. That's why you see the extra parentheses here. Anyway, let's proceed with files. They're not difficult at all. But you'll find them difficult unless you do some exercises. Okay? And here is the summary. We do file I/O, but you got to detect end of file when there's no more data. So pseudocode also how to open a file and close a file. Close is missing from this list. Read, write, end of file. Why do we open a file? To allow input or output to that file. Without opening it, you cannot do either one. So we'll take 3 or 4 examples. Suppose we have, this is an example of file input output without a loop. So suppose we have a small file with the following data. John Doe, name of a person, and 3 grades, 70, 90, 85. All we need to do is figure out the average of the 3 grades. Now this is a file I/O problem, no loops. So we just have fixed data. Why would you use a file in the first place for input or output?
It has a lot of text in
If you have a lot of data, you don't need to type it again and again, right? That's what we've been doing all along. So can you extend this file to hundreds of records like this? Yes. And we are coming to a file I/O problem with loops in a minute. Okay? That's when we'll need end of file detection. So this is very simple. The input file has to have a name and we call it data.txt. You can call it anything you like. And the output file has to have a different name because normally you should not write onto the same file. Okay? At least we are not learning that yet. You can do that in future classes, you learn about it. Okay, so the average is calculated by adding the three numbers and dividing by 3. So that's the correct answer, right? Any questions so far? And this is the pseudocode. Start, stop, indented algorithm. First you open and read the file. Here, open the file means make sure it's available to read. Read the name out of that file. Read the grade 1, grade 2, grade 3 from 3 lines from that file also. Close. Why close? We don't need it anymore, right? So this close can be at the end also, close data.txt. So we are done with entering all the information from the file, not from the keyboard. If you wanted it from the keyboard, all you have to do is eliminate open, eliminate read data.txt, just read the name, right? Read grade 1, grade 2, grade 3, leave out data.txt and leave out the close. So that would be the ordinary way of doing it from the keyboard. Now we are ready to write to the output file whose name is SOL solutions.txt. Open it. We are writing the name first. The plus is for concatenation, right? Calculate the average. Why divide by 3.0? Because it can be a real number, right? Even if these are integers. And write the second line into that file, close the file. So is this logical? Do you have any questions on it? Because pseudocode is important. I mean, I've been teaching it all along because you get a rough idea of the algorithm, a precise idea by doing Python or Visual Logic. Now, in Visual Logic, I have not had the opportunity, I haven't taken the time to figure out if you can do file I/O. Does anyone know? If you've read the manual?
I've done some file on Python.
No, not Python, Visual Logic.
I don't know.
Don't worry about it. We are not going to do it.
Or
Python.
you can do anything you want to with Visual Logic if you can just figure out how to do it.
Yeah, if you can do
Non-documented.
file I/O, it may or may not be documented also in that little tutorial I put on. So we are not going to do it for Visual Logic. This is just pseudocode and Python. Okay. So flowchart, of course, we can do anytime. We are not going to execute it. Same logic. Open the data text file for reading. Sometimes you have to specify for writing or for reading in different languages, like COBOL or something. Read name from data.txt, read the 3 grades from data.txt. So the only difference is mentioning this phrase from data.txt and then close it. This would be better if we open the file solution.txt or sol.txt for writing. Then write name, because sometimes the operating system needs to know whether the file is open for reading or for writing or for both. We'll not do both. Write name to solutions.txt, figure out the average, write the average, and close the file. So this has no loops, right? Will it process the data from that file? Hopefully so, but we are not running it yet. The Python we will need to run. Here's the Python. Please note the syntax very carefully because I'm not going to repeat it too many times. This is known as the handle sometimes. When you open the file, that's the file name on the disk for read and W for write. You can put in double quotes, I believe, but I haven't tried lately. This can be a variable too. For example, if you need to know the file name from the keyboard. And if it fails, it will stop right here. If you can't open the file, if there's no connection made between infile and data.txt, it will give you a red error message here. But I'll run this and at least the loop version and show you precisely what needs to be done. So this is the syntax to read the first line in its entirety. Whatever you have in the first line, it will read into name. Whatever you have in the second line, it will read into score 1 as a string. So you need to use int or float over here, right? Same thing for score 2, score 3. And read line means go to the next line and read. So you're going to read 4 lines of data, right? Then close the file. In file is the name of the file we opened. Out file is the output file. Open it for write and call it solution.txt. If it exists on the disk, it will be overwritten. And S1, S2, S3 are the integer versions of score 1, score 2, score 3. Figure out the average, because you cannot do score 1 plus score 2 plus score 3, why? Because they are strings, it will do concatenation, right?
So
So
you just converted them to integers.
that's what we did. But I'm saying if you use score 1, score 2, score 3,
Okay, gotcha.
then they'll be strings and it'll do concatenation, and you can't divide a string with 3. So you write this string into the file. Now this may write on the next line or it may write on the same line, I don't know, it doesn't really matter. And then write average equal to, convert average into a string and then write it out, which makes sense, right? And close. So it's very important to run something like this on the sample data. Yes?
Visual Logic supports file input and output.
File input output, thank you. That's very good. Is it in the documentation we put on the
No.
disk?
No.
No?
I just put an input statement and an output statement.
Okay.
for Check to see it.
Okay, thanks.
not
So
a question.
any other questions on this Python program? Straight line code, no loops, nothing, no if statements? Yes?
I noticed that you converted the average to a string. Will it not write an integer or a float?
It may write it in binary or something. You can try it. Matter of just removing the str, right?
Yep.
And then you may not be able to read the file for output. And the purpose of writing a file is that you can use it for input in another program, right? You can take an input file, process it, produce an output file, and then write another program to produce some more output. Anyway, I'll run some of this. This one is a file I/O problem with a loop. Maybe we should look at the data first. Here's the data. Pat Smith has 3 tests, scores on 3. Chris White, same thing, etc. 4 students and 12 exams. We've got to detect this end of file ourselves, because this is called end of file, no more data. And the output is shown here. Pat Smith has an average of this, etc. Okay. So that's the input, that's the output, that's the file name for input, file name for output. And again, you learn more if you run it yourself. If I run it and you're asleep in the class, no, that's a bad joke. If you're asleep, then you don't get much out of it, right? Okay, so this is the pseudocode. Open the file for input, that's data.x. Open the sol.txt file for output. Now, we've not mentioned read or write here. It's a pseudocode. You can assume that or make it more explicit, right? So this read means you're going to read from that file. And once you start reading, you should not write to that file. That's the default in a lot of languages like COBOL. They're called sequential files, by the way. There are also ISAM, index sequential access method, if I remember from a long time ago, and many, many other direct access files and so on. So once you read anything from an open file, then it's meant for read only at this time. While not end of file, EOF is standard for end of file for the last 60 or so years. Read the 3 grades from the file. Sending information to the output file, write the name. Now, in pseudocode, you don't need to convert to integer and all that stuff, right? You can assume they've been converted somewhere. Divide by 3 to get the average, write the average. Read the next name. Why do we do this? For the loop to keep going, otherwise you would have the same name. Now, this is a mistake, obviously. This read grade 1, grade 2, grade 3 should be pulled out, right? Because we already have it here. We have not been very careful. We make mistakes all the time. End while, that's the end of this loop. Close the data file and close the solution file. So this is the pseudocode to process that file I showed you, or any file which has that format. Name, 3 grades, name, 3 grades, could have 100 students in it, it should still work, okay? And that's the flowchart. Open the data file for reading, solution file for writing, read the name, and then read the 3 grades if we are not at end of file. Then do the calculations in writing and read the next name. This is very important, so you don't have an infinite loop of some type. And then keep processing till you're done with the file. When you're done with the file, if you forget to close the file, Python closes them automatically. No big deal. But sometimes if the program crashes and the files are not closed, for input file it doesn't matter. For the output file, some of the data may not get to the file. So it's a good idea to close them every time. Any questions on the flowchart or the pseudocode? Then this is the program with the loop, and please note this is the end of file check. Open the data file for read and the solution file for write. Read the first name, and it will read the null name over here when there's no more name, right? So after this, do not type an enter, or maybe you do have to type an enter, but do not type any data, even a blank here, because this will not be true. So as long as the name is not null, null means absolutely no characters in the name. Read the first grade, second grade, third grade, and convert to integers. Write the name, this is a new line character. So it goes to the next line here. Figure out the average, write the average, convert it to a string, and go to the next line. Read the name again. So this one does not have the error where we are reading the 3 grades over here by mistake, okay? And the indentation tells you that the while loop is done here. That's very important. Some of you overlooked it in the test too. Keep going till you have processed all the data. When you've read 88 over here, you write out Josh, Kathy, and 88 happens to be the average. And then you come to this line. Try to read the next line. There is no name, right? So it reads the null string, or at least this becomes false. So you come here and close both files. So this program works, and I can run it and show you, just to show you how to create the data file and all that. And it may be on the code samples. We'll see in a minute. Let's finish the rest of this. Self-check. Okay, you can do this yourself. Another file IO problem with the loop. Very similar. In fact, all file IO with a loop, the structure is similar to this. While not end of file, keep going. And when you finish the file, then close some files, etc., and write some information to it. Now, let's see what are we trying to do here. Go to the data. Here, Pat Smith has taken an unknown number of tests. In this case, 6. Could have taken 3 tests. We are supposed to figure out the average and print it out, or write it to a file. This curve thing means go to a file. This is input from a file. Okay? Keyboard is rectangular, right? Input, output. Okay, so Pat Smith could have taken 1 or more tests. Should have taken at least 1, otherwise you get a 0 divide error here because the count would be 0. And let me go back. Okay, let's do it backwards. From the Python, we'll go back to the pseudocode. Open this for read. Open solution sol.txt for write. This file has nothing right now. Read the first line, get the name. Read the first grade, because we are going to check for grade being not null over here. And count is 0, that's how many grades we read. Actually, we could have initialized to 1, but it all works out. Sum is 0, because we're going to add float of grade to, I don't need float of sum. Accidentally it's there, because we initialize it to a real number anyway, so we don't need it. But if it's there, it doesn't hurt anything. Then read the next grade and keep going till there are no more grades, right? And again, grade is a string for that reason. We are checking for null. We have not converted to an integer or float yet, because it's easier to check for a null over here. Okay? It will not automatically be 0 after that. It will just not have a value, right? Okay, so close the file, write the name of the person, divide sum by count, and write this out. And if you have a calculator or on the computer, you can figure out if the average turns out to be 78.33. Any questions? Let's go backward now. The pseudocode and the flowchart are similar. Pseudocode is in English, so it doesn't really have to work precisely. Read the grade here, read the name here. Count and sum have to be initialized for this to work properly. And we write while not end of file. A lot of languages use that syntax. And you need to give the name of the file or the handle of the file or something to indicate which file it is that you're reading from. So if you go through the pseudocode, it should match your Python code. Actually, we should do the pseudocode first or the flowchart first and then the Python code, right, to debug it properly. This is also very similar. I'm not going to repeat it. It's very similar to this. Only improvement I can think of is leaving the float parentheses out from this sum plus float. Now there's yet another example. Name of a person, what they've bought, for what price, and the tax. Same format. Mary has bought a scarf for that price and the tax is this much and so on. So what you're supposed to do with this input file is, and it's called purchase.txt. Write out the name of the person or patron, what type of item they bought, and the total cost, including cost plus tax, including tax. So it's very simple. You just have to add two numbers. Can you predict Juanita Story has bought a shirt for a total of $5.17 or something like that. It's the first line in the output. Now you don't have to write it in print.txt, you could just display it on the screen, right? And this is the flowchart for that. And this is the output file, 517 with a $sign and all that. Any questions on that? I don't know if you have the Python, but you should very easily be able to do that. So we don't have the Python code for that, but it's a good place to start. Convert one of the earlier codes. Conclusion, I won't bother, but file input output basically helps you process a lot of information. For example, if you can process the paycheck every month for the same set of people and same number of hours or rate or whatever it is, then you don't have to type all that data in, right? So please focus on the exercises of this chapter. And as I said, you'll have at least one problem, maybe more. But now it's time to do the code samples. Okay. And file IO should have file in their name. File many grades, file IO simple. Let's do the simple one. This time I'll start the write Python, not 2.7.8. Here 3 ID. And then file IO with many grades is that one. I'll just do the simple one. You do the one with many grades. And then write the one with the purchase.txt. Okay, so open the file. Which one? This one. File IO many grades. So which name? Why drive? Code samples. File IO with one grade. Without loops. Here, this one. Okay. So this straight line code, no loops or if statements. Open this file for read. Where should be the file? Where should the file be? It should be under the same subdirectory. Unless you want to give a more complete name for the data path with backslashes and all that stuff. I don't want to get into that. You can just experiment. It's not important. So it will connect it to the file if it's in the same subdirectory. Okay? Let's examine the data file first. Edit with Notepad or something. See, it has John Doe in the first line, 70, 80, 90. I don't want this. If you hit enter, you'll have line 5 also. It may or may not detect that as end of file. So it's best to have this format, okay? No double quotes or anything. So let's just minimize this and run this program. Read the 4 data items, close the file, etc. Go through the same logic, let's run it. There was no output. Why? Because on the same subdirectory it creates solution.txt. This one. .txt is standard for a file which can be edited with Notepad or Notepad++. This is the output it just produced. Now to verify that it does work with the program, what you do is change the data file, right? A little bit. Where is the data file? Here. Change some of these numbers to 75, 85, 95, for example. And then see if the output file changes accordingly. That's the only test, right? Because the program produces no output. Or you can modify the program by putting a print statement along with outfile.write. Can you not just print name, double quote on the screen also? Yes. And then try, like you said, without the str and see what happens. I'm not going to do it. It's an assignment, class assignment. And there's solution 1 and solution 2 because of file IO with many grades. Let's see. It opens 2.7.8, but this is the solution 1, okay? That's where it's coming from. And let's just take a look at the output file with Notepad++, and it's this, Jane Doe with this. Where's the input file coming from? data1.txt. So let's open data1.txt also and sort of verify that there's the same example in the book. Jane Doe has taken all these tests, 7 of them, and therefore, where's the output? I've forgotten. Here is the output. That's the average of the 7 tests, okay? Can you not make it 10 tests and things like that and try it out? Yes. So I'm going to sort of stop here unless there's a question or two. I don't remember where solution 2 is coming from. Let's take a quick look at it. Same sort of thing, but I can't tell. Yeah, John Doe 80. It probably is the same example as the first one. This one, I just called it solution 2 and changed some of the data in data.txt. Okay. So once again, this code samples is there for a reason. I forget to do some of the examples, so that's why I put them here. For example, print numbers backwards is useful for the last assignment. Compare 3 numbers. Functions, I've forgotten where it is. Function for square, we're going to discuss that, but you can always read ahead, right? Or read backwards in this case, previous chapter. Nested loops, that's useful. Multiply nested loops is also useful. Pay example was for one of the assignments, all you had to do was put a loop in there. Test append is useful, etc. While loops are useful. Tracing is useful, it will be on the last test. Do you have any questions? Oh, there's one more I can put on code samples if you want it. Now these are complicated examples, so if you don't understand all of it, don't worry about it. You can always create a data file, run it, etc. I have a couple of examples on the Z drive, which I don't bother putting on this because sometimes it's overwhelming. Yeah, midterm grades easier, I'll put both. CSC 120 midterm grades and final grades. Of course, being a computer person, I like to write programs to do that and not do it by hand, right? Make mistakes all the time. So I'll copy these two, and if you're curious, you will run them. If you're not curious, then you won't run them, obviously. Paste. Okay, one more example. This one is the most complicated of them all. I wrote this a couple of summers ago to predict stock value or something. I'll run it give me 1 minute to paste it here first and show you what it does. Paste. And a student who was getting bored in my summer class translated this to Java and got it to work. He's just a sharp student, right? Start. Do we have Python already? Python 3.3 doesn't run under 2.7, by the way. Stock prediction means open the file, recent file, Do you see stock prediction anywhere? No, I don't. Okay, we'll just go to that file then. File, open the Z drive. What's the name again? Stock predictor here. This is the date, 2013, 6/6, 6/4, and finally 2014. So that's the one we want. Okay, it's about 150 lines long. Let's see, 160 lines long. And I won't tell you much about the code, but just run it, okay? So give me the name of a company you like, Apple or IBM, or for which you know the code. I'll try Apple because that's going to be $1 trillion company in a few months, this year sometime. So do you want the history for 5 to 50 days? I'll say 10. So in the previous 10 business days, what's happened in the past 10 days? April 13th, which was yesterday, it opened at $128 and closed at $126. So it went down, right? And so on. Adjusted price, close price, and close time, whatever it is, including splits. You got to know a little business terminology for that. So here are the 10 days, not counting 12th and 11th because there's Saturday, Sunday. And what are these numbers? I don't remember. But basically it tells you that it went down 25 cents one of these days. We are going backwards. So open was this, close was this. Anyway, so it does a rough calculation. How many times it went positive, how many times negative. 4 times positive, 5 times negative. Total value positive was $4.60 and negative $4.12. So do you think the trend is sort of upwards? Yes. So there's a 40% chance that it'll increase today by $1.15 and a 50% chance it'll decrease today by that much. Oh, this must have been an older version. Anyway, I got a more recent version, just slightly different. So relative to yesterday's price, we are predicting it will go down 4 cents today. Okay, but don't base, any investing that you do on this. It could be wrong, right? So I wouldn't put my money on this. But let's just out of curiosity see what it's doing. What it's doing is it's accessing a web page called finance.yahoo.com, and let's see if it's gone down or up today. Finance. Okay, the stock market is up 90 points, and Apple was recently added to the Dow Jones, I believe, 30. What's it doing today? I remember there's a way to, look up Apple somewhere. Here, I can barely read Apple. It's down 23 cents today. So the prediction is that it will be down 4 cents. At the end of the day, see what's, it's down 15 cents, 14 cents, etc. So it varies every second or less. I'll stop here.